Welcome back. I hope that you guys were able to enjoy playing with the roller coasters last week. The Jason program is an amazing online resource, and I hope that it wasn't too tedious and then you actually did kind of enjoy building, and several people did get the extra credit, which was awesome, and I was thrilled to see that. Genuinely excited to see that much effort, and I appreciate those people who put in the work. And I also hope that in the process of doing it, in the process of watching those coasters go again and again and again, that we noticed this bar. And we noticed that the higher up the roller coaster went, the more PE you had. The lower to the ground you went, the PE went away, and as you lost potential energy, you gained kinetic energy, and vice versa. So when you were high in the air and not moving fast, you had a ton of PE and not a lot of KE. As you went down, you lost height and you lost potential energy, but it was transferred into kinetic energy. That is, in essence, the law of conservation of energy, which is why I wanted you to play with the roller coaster in the first place. Unknowingly, you probably did gather some basic concepts. Okay, so we have done a problem like this before, but I want to add a little bit more math to it. The total energy is always equal to the sum of potential and kinetic energy. We're not going to do dissipated energy. We're not going to do friction. We're just going to say that TE equals PE plus KE. We know this already, but I'm putting it down again just so we can see it. Awesome. So in this case, we know what the total energy is. If I say that this boulder sits right up here, the total energy is PE plus KE, 500 plus 0. Bam, 500 joules. Easy. But let's just say it falls down. And as it falls down, I say that right here it has kinetic energy of 150. Now I know that these two must add up and equal 500. So 150 plus what is 500? 500 minus 150 is 350. Okay? Now, what if I say right here, the potential energy is 100? I know that at this spot, so what this is this isn't three different boulders. It's the same boulder at three different points in time. And what I know is that the potential and kinetic energy always have to add up to 500. So if you can find one spot where you can get the total energy, you know that's going to be the total energy for all spots. And every spot has to add up to that same number. It's not always going to be 500. It's always going to be the same number. And then as this hits the ground, the moment before it hits the ground, it has 500 joules of kinetic energy before it gives the energy to the ground. Okay? But here's my question. And here's what I want to know. I said this is a 5 kilogram boulder. What is the height right here at the very top? How could I do that? Well, if I want height, I know that's connected to the PE equation. We did that a while back. And this is really important that we remember these equations. They aren't going anywhere. If I want the height at this top part, height depends on potential energy. So I'm going to use the potential energy equation, the only equation that has an H. I know that the potential energy is 500. 500 equals 5 times 10 times H. We had a whole assignment where we had to solve for H's and velocities, and that's why. Because I want us to be able to look at these diagrams and really understand how to get everything about them. When I go ahead and do this, I know it has a height of 10 meters. What if, let's just pretend, what if I wanted the velocity right here? I wanted the velocity at this spot. In order to solve for the velocity at this spot, I have to use the KE equation. Remember, when solving for height, you use PE. When solving for velocity, you use KE. Here's the KE equation in case you forgot it. At this spot, I have a KE of 400 joules. 400 equals 1/2 2.5 V squared. I do want to solve this out because a lot of people did mess this up in some of the math, so I want to go over this. I'm going to take half of 2.5. So when I do 2.5 divided by 2, I get 400 equals 1.25 V squared. The square just stays on the V. Then we divide both sides by 1.25. 1.25. Okay? So 400 divided by 1.25 is 320. And then I just got to square root that. And I get 17.89, because I rounded, meters per second is my velocity. So when I look at this screen now, there's a lot of work that appeared. We figured out what the total energy was. We found the PE and KE at every spot. And once we had the PE and KE, we could then solve for either the height or the velocity using the information that's given. That's what we're working on today. So a 10 kilogram ball is rolling down a hill. What is the total energy? So the first thing you need to do is get the total energy. That is really important. Okay, so how do I get the total energy? I have to find a spot where I have both a PE and a KE. There are 4 spots on the screen. 1, 2, 3, and 4. Spot 2 has a PE and KE. So what I'm going to do is I'm going to add them up. 700 plus 500 is 1200. So I know that every single spot in this problem has to add up to 1200. So what was the KE at spot 1? If this was 1,000, 1,000 plus what is 1,200? This had to be 200. Nice. Okay. If this is 720, 720 plus what is 1,200? 480. Yes. What is the KE here at spot 4? It's got to be 1,000. Nice. Nice. Okay. So what you do to fill in these blanks is you find the spot where you have both a PE and a KE and you add it up. That's how you get the total energy. And once you have the total energy, every spot has to add up and equal the same thing. So that's how we got these numbers. They all have to add up and equal 1,200. But what if, let's just say, I wanted to get both the height and the velocity right here at spot 3. How could I do it? Well, to get the height, I would have to use the PE equation because height depends on PE. PE equals mgh. Now, the height is always changing. So when I solve for this, it's only going to be true for spot 3. The potential energy is 480. What's the mass? Oh, the mass is 10. 10 times 10 times h. 480 equals 100 h. Awesome. Divide both sides by 100. 4.8 is the height. That's it. That's why we went over this math before getting here. We can now use these diagrams to figure out the height and velocity at each point in time. Well, how are we going to solve for the velocity? Well, height is determined with potential energy. Velocity is determined with kinetic energy. So check this out. KE equals 1/2 mv squared. KE is 720, 1/2, 10 v squared. Check this out. Half of 10 is 5. Again, the square just stays on the v. Then I divide both sides by 5. And I get 144 equals v squared, square root that, and I get a velocity of 12. Nice. That's how you do it. So, Bizzuto, could it get any more complicated? Why, yes. Let's just say that little Susie took up tightrope walking. Here she is. She is tightrope walking. And little Susie somehow fell. And here she is fallen at 3 different points in time. So this isn't 3 different people. It's her getting faster as she falls to the ground. Okay? So she has a mass of 48 kilograms. I don't have any PEs or KEs, but I know that PE equals mgh. And I know that KE equals 1/2 mv squared. All right? So here she is at rest at the top. I have no idea how high she is, but I know that if she's at rest at this very first spot, I know her KE is 0. This is a puzzle. We are going to jump all over this problem to solve it. We are not going to be able to solve it in order, and you have to feel okay jumping around. We have 4 spaces. 1, 2, 3, 4. All I need is 1 space where I can get both the PE and the KE. I can add it up. And then once I have the total energy, I can figure out what the missing energies are. Bizzuto, that was a lot. I know. Just stay with me. Let's look at spot 2. Here she's falling 6 meters per second. That's a velocity. With a velocity, I can get a kinetic energy. KE equals 1/2 48 6 squared. For simplicity, I know we can do this. I'm just going to type that in my calculator. When I type that in my calculator, I get a KE of 864. Now, I have no idea what the PE is at either of these spots yet, but that's okay. I'm going to fill in what I can, and then I'm going to jump around. Here, in spot 3, she's moving 14 meters per second while 7 meters high. Oh, that's interesting. We've got 2 pieces of information. With 14 meters per second, I can get the KE. So I can do KE equals 1/2 48, because her mass never changes. Her mass is going to stay the same. 14 squared. I'm going to type that in my calculator, and I get 4,704. Huge number, but that's okay. What can I do with the 7 meters high? Oh, with a height, I can use the PE equation. PE equals mgh. The mass is 48. The g is 10. The height is 7. 48 times 10 times 7. And I just type that in my calculator. And I get 3,360. Okay, I filled in what I knew there. And now some people might recognize what you can do with that. But if you don't, that's okay. I'm just going to fill in everything I know. So I'm going to go in this last spot. Here she's 2 meters high. When she's got 2 meters high, I can use a PE of mass times gravity times height. And I type that in my calculator. And I have a potential energy here of 960 joules. Okay. But how do I get the blanks? Here's the key. I said the total energy equals PE plus KE. Find the spot where you have both the PE and the KE, and then you can get the total energy. And this is what some people notice with spot 3. Because we solved for both the PE and the KE there, we can now go ahead and simply add them up. We have a total energy of 8,064. I'm just adding the PE and KE from spot 3. You cannot add the PE from spot 4 to the KE from a different spot. They have to be in the same spot. So you couldn't mix and match PEs and KEs from different points in time. They have to be in the same point in time. This is the only one you can do because this is the only one where you have both the PE and the KE at the same point in time. But now that I know that, every spot has to add up and equal 8064. Every spot has to add up and equal 8064. So check it out. 0 plus 8064 equals 8064. 8064 minus 864, the potential energy here is 7,200. Here, 8064 minus 960 is 7,104 joules. So, this is it. Every spot adds up to the same total energy. And that's how we were able to get this. So, there's a lot of stuff going on here. But let's see if this makes sense. As she falls, we expect the PE to get lower. 8,064, 7,200, 3,360, 960. That's consistent. As she falls to the ground, the PE decreases. We expect that as she falls, she's going to go faster, which means the KE should increase. 0, 864, 4,704, 7,104. It's consistent. As one goes down, the other goes up, and they always add to equal the same number. And we got this number from the one spot where we're able to get both the PE and the KE. This is the type of problem that I expect us to be able to do at this point. I know there is a lot of math here, but there is nothing you can't do. you're bored, feel free to just stop by and say hey in office hours. Love to catch up with some of you guys and see how you're doing. That'd be great. I hope all is well, and I wish you luck, and I will see you guys on Wednesday.